Hello everyone, my name is Coleman. I'm a product manager in AWS monitoring and observability. At AWS, we have a broad selection of monitoring solutions and tools, as you may have already heard from some of my colleagues in the earlier sessions today. In this session, I'm going to talk through some of our AWS-native solutions and share some best practices, tips, and ideas, and even mention some of our newer features or additions that might be of interest. Hopefully together, these can help you enhance your monitoring and observability for your applications currently running on AWS. When we talk about monitoring and observability, it's usually through the lens of getting better visibility into what's happening in our applications and taking better actions to improve our end customer experience. And now more than ever, a customer's digital experience is their customer experience. If I think of examples in my own life, even in the past day, I paid for parking in the city using an app on my phone. One of my kids bought and downloaded a game on their pad. And I streamed a movie through a subscription service last night on my TV. I've been a customer of all three of these providers for many years, and I've never emailed, spoke to, or met a single one of their employees, let alone went to a store or an office. So more and more, the digital experience is becoming the customer experience. And this is often our customer's first and only impression of our services. We want to better understand what's happening in our systems, see it, and be able to react to achieve our business objectives. It's really about, in my mind, getting the right signals flowing. How do we get the metrics, the logs, the traces? And then when you have those, how do you quickly detect, investigate, and remediate as issues occur? And generally, the faster and the better we do this, the lower the mean time to resolution, and the better the end customer experience. Thinking about modern applications and architectures, they can also have some unique qualities and attributes compared to more classic architectures. And it's sometimes helpful to think about these so you can incorporate and utilize them within your observability strategies. For example, applications are increasingly using containers, serverless like AWS Lambda, scalable compute, and it's more and more of these type of resources being used. And now often applications are a mixture of many types. Also, compute's becoming more ephemeral and dynamic in nature and faster changing. Like historically, maybe you logged into a VPN to remote triage a server or looked at a physical rack of servers. Now pieces are coming in and coming out super fast and very often. And one way to think about this is the actual unit of compute is getting smaller and smaller. Things now live for minutes, not months. And they spin up, they spin down. And it's really about optimizing the running of those, but then they generate a lot of telemetry and data. So now we have more metrics, more logs, more traces, and the opportunity to collect more data. Also, applications are becoming more distributed, both from an architectural perspective, but also cross-account and cross-region. So companies often use multiple AWS accounts to run a single application or have your own business split into multiple accounts for your own purposes. So things are becoming more dispersed and more spread out. So thinking about all these together, our desire to reduce MTTR and deliver great experiences and the sort of new rules of modern applications, here's some tips and ideas that may help. So starting with containers. As we mentioned, containers are dynamic, they come and go, and they have the potential to generate a lot of telemetry. And customers want to collect the most important signals and include these as part of their wider monitoring and observability. So you can really think of it as a multi-part journey. 1, pick them up as they come and go. 2, get the telemetry off them. And 3, turn this into insight or action to help your monitoring. CloudWatch Container Insights is the AWS-native solution that provides out-of-the-box curated experience for monitoring your applications and microservices. Once you set it up, Container Insights automatically sends metrics from many resources like CPU and memory, as well as performance logs to CloudWatch. It includes a set of pre-built visualizations so you can see the performance of your clusters and nodes, and also some out-of-the-box workflows. It works on Amazon Elastic Container Service, Amazon Elastic Kubernetes Service, and Kubernetes platforms on EC2, and also collects metrics from clusters deployed on Fargate that are running on ECS and EKS. If we take a little example, the picture on the right is showing us we've enabled Container Insights, and now it's picked up our container environments, and the data is starting to flow. We get a sort of a hierarchical view, which can be super useful in this dynamic world. You can now visually see where things are. You can see the clusters, the namespaces, the pods. Looking a little bit deeper into this one, we can now zoom in and zoom out. So we can select specific namespaces or pods. There's also tabular views where you can see all this data. So there's filters and sorts if you prefer to look that way. Also, as I mentioned, the data starts to flow to CloudWatch. So you can create alarms on these metrics. So in the example here, we have a particular node that's alarming because the memory usage has risen above the threshold. We hover over, we get some tools and some tips, but we can continue to dive a bit deeper. If we open the Performance Monitoring tab, in the middle here, you can see the memory utilization is starting to spike. So this is the item that alarmed on it. You can also see some other metrics here like CPU utilization and network. And this is an example of the automatic metrics and the out-of-the-box visualizations I mentioned earlier. And these can be very powerful. So if you think again about containers being short-lived, that come and go, instead of now thinking about connecting up each one and what telemetry to include and what dashboards to include, these come automatically pre-built as a starting pack. Also, because these resources are ephemeral in nature, there's a chance that you can be looking at stale or old data, that it doesn't always naturally flow through. Container Insights is automatically pulling the latest data in to help with that. Going a step further, you can also use this data downstream and you can extend and customize. So the metrics are viewable in the metrics section in CloudWatch, which means you can create things like metrics insight queries, and I have an example of those a little bit later. You can also create alarms, as we mentioned. You can create customized dashboards. The metrics are actually automatically generated by CloudWatch from wider events that Container Insights is collecting. So you can actually deep dive on those items using log insight queries, or you could deep dive on the X-ray traces. So once you set up Container Insights, you get these kind of out-of-the-box connections, you get the standard metrics, standard visualizations and workflows, and then you can include those in your wider observability and customize them to fit your business needs. Going back to our starting list, we talked a little bit about containers. But in the case of containers, and wider than that, things are getting more and more dynamic, and they're generating more and more telemetry. So it can be challenging to look across that ocean of data to quickly find the patterns and get the quick answers that you want. As we mentioned earlier, observability, it's super important that you quickly find the root cause and patterns to help you remediate. Imagine you have an expansive, complex application using a number of services and components, and you've seen a degradation in performance. Where can you start? One powerful tool is CloudWatch Metrics Insights, a high-performance SQL query engine that you can use to query your metrics at scale. You can identify trends and patterns with your CloudWatch metrics in real time. You can use this on any metrics in CloudWatch, so it could be the Container Insights example that we talked about earlier or any other service. And when you open the CloudWatch console, you can choose from a variety of pre-built queries, or you can run your own. So if I take EC2 as an example, say you have 100 or 1,000 EC2 instances running. You open Metrics Insight, you pick EC2, and on the right-hand side, you can see example queries like top 10 instances by CPU utilization. And that's a great starting point to provide some early insight. So that's a pretty simple example, but Metrics Insights is built to be fast at scale. And it's really at this stage that Metric Insight starts to come into its own, when you want to slice and dice your metrics at scale. And that's a key benefit. You can publish your metrics just once like you do today, but now you have the flexibility to quickly aggregate and filter the metrics by querying as and when you need. You can use the builder view that we looked at on the earlier slide, which interactively prompts you to kind of filter through your metrics. You can use the out-of-the-pack queries and edit those. You can start with a clean sheet of paper. You can use group bys to lock in on the specifics. You can also use the order by to decide what the top N items are. Likewise, you could take ELB and load balancers and filter by availability zone, or really any dimension you want. So this gives you a super powerful way to slice and dice what you want. And it can be especially helpful when you're dealing with high cardinality metrics. So these are metrics that maybe have a high quantity of dimensions or attributes. There's also a SQL query capability, which can be great for users that are more familiar with the SQL language. They can also do these sort of sorts, filters, and joins using SQL, so remove that learning curve. You can also create alarms based on metric insight queries. This is a feature that we launched towards the end of last year that's pretty exciting. So if you think about the dynamic compute, sometimes you want to be able to spin up and spin down resources as you need without the need to create alarms each time this happens. Metric Insights enable you to do that. You create your query, you run it, you say, yes, that's what I want, and you create an alarm on it. And then once it's defined, that query runs in the background. It looks for new items that match the criteria as they spin up and spin down, and it applies this alarm logic to them. So for example, you could say, alarm me on my EC2 instances with dimension XYZ that gets stuck on over 80% CPU utilization for more than 5 minutes. You define the alarm criteria and you're off and running. And it sort of automates the alarm coverage here in dynamic environments that minimizes the chance of having blind spots. You create the alarms that watch over the dynamic fleet, and they apply as the fleet changes, increases, and decreases. So sticking on the topic of alarms, if you think about your objectives, SLAs and SLOs, and what you want to monitor and excel at, alarms are often the first line of defense. They alert you that something is out of your usual band and you may need to remediate. We use alarms a lot on Amazon, but with everything else, there's no really right or wrong way. It's more around finding what's best for you. Just to talk through some of the kind of example common patterns. Metric insight alarms we just spoke about, these are a great way to apply a specific criteria to a sort of a dynamic setup and dynamic use case. Metric alarms, this is probably the most common one people think about. Here we're setting an alarm on a single metric with a static threshold. For example, disk usage is above 90%. We're comparing to like an absolute figure. But within that, there's some pretty interesting things you can do. For example, you could alarm based on percentile. So let's say you're monitoring the performance of requests handled by your application load balancer. You can set an alarm on a P98 percentile, and that helps you identify the 2% of traffic that's above your goal. And these type of alarms work really well, especially around things like latency and requests. Another interesting one that's a sort of a variation on that theme is trimmed mean, and this is one we use quite a bit in Amazon as well. This allows you to measure the average customer experience. Let's say you take a trimmed mean of 99%. You take 99% of the data and you disregard 1%, which is often the outliers. And you can think of it like imagining that bell curve, and you say, calculate my data and alarm, but exclude certain bounds, left or right. And it gives you a more representative sample of the metrics, especially if some of them are open to sensitivity or variations. So even within classic alarms, there's a lot you can do. Sometimes as well, there's parts of your business that it's normal for things to fluctuate, and you'd actually expect this over the course of a day or a week. A good example of this is like an online shopping system or an online shopping site where there are peak customer hours. In this case, you can use alarms based on anomaly detection. So our machine learning anomaly detection algorithms will train on your data to define your normal data patterns and then alert if you go outside of these bounds. So you can set up a threshold to say, alert me if I'm below a value, above a value, or go outside of a range. And if you think of this example, this is the metric data points. And anomaly detection is calculated kind of a normal range for the inputs you provided. And then these red peaks are out of range. So what you can use this for is to create specific alarms if you go out of these bounds in a kind of a scenario where you do expect peaks and troughs. So I've mentioned a few alarms already, but often the health of our applications are driven by many things. Once you define your objectives and the key measurements, it's important to look through this lens. So sometimes it can be helpful to consider a range of things within an alarm. For example, a mix of memory or CPU and application performance. And this is where composite alarms come in. In essence, they're alarms of alarms. And they work great if you want to trigger an alarm based off, say, 2 or 3 individual conditions being met. You can really think of it like an AND clause. Alarm me if and. And they're a great way to kind of observe the overall health of an application, but also reduce the overall quantity and alarm noise. So in summary, it's best practice to use a mixture of these alarms depending on your use case and your objectives. So we mentioned alarms are often the first line of defense to know that something to be addressed. And on Amazon, we often embed links to customized rich dashboards directly in the alarm. Imagine the alarm goes off at 2 o'clock in the morning. We mentioned already that alarms don't sleep. A well-built dashboard with the key views and information can be a great tool to help our engineers get the visual clues and signals to better understand what's happening fast. It's all about reducing mean time to resolution, so every little bit helps. CloudWatch includes many automatic dashboards and out-of-the-box visualizations, but you can also build your own. So you know your business objectives best, so therefore you can pick the best like telemetry and metrics to use. But equally important is the lens that you look through those, because that helps to visualize that signal. So CloudWatch includes a palette of different visualization widgets. You can tell your story through the lens that fits best. So think of that alarm going off at 2 o'clock in the morning and imagine it's driven by a spike in CPU utilization. Using something like a gauge here is very impactful. You can see it's red and it's 95%. The user's eyes are immediately drawn to this. And maybe you could have a follow-on more classic line chart that shows like the performance of that metric over the last 1 or 2 hours. So you could see, how did I get to 95? Was it sudden? Was it slow? And maybe you could also include another drill down that shows what's it look like for the last 2 or 3 days. So you can see, what is it now? How did it get there? And what normal looks like. So that sort of 360-degree view can be super helpful. Maybe in the cases you can include an example like the bottom right here, which shows alarm status. And that can help see, are there multiple alarms firing? Because maybe there's some link or some causality. The example up in the top right, I think, is a good way to represent a view of time and duration. So for example, this could be response time or latency. So you get the latest value here, but you also get to see a recent trend line. So you can see things are trending up and trending down. So far I've been talking about dashboards for operational events, but dashboards have much wider use than that. For example, on continuous improvement, you could create dashboards if you're running a campaign to improve average page load times, for example, and many of these concepts still apply. So often with dashboards, it's about thinking about the primary, secondary, and supporting data and how that can be best positioned and presented to maximize the visual signals in the story. And there's a wide range of widgets and ways to help with this in CloudWatch. So far, we talked about containers, compute being more dynamic, and architectures generating increased volumes of telemetry. Often customers are also using multiple AWS accounts. This can be for a range of reasons. For example, maybe you have an application that's built using separate AWS accounts for separate services. Or maybe your business is distributed across different AWS accounts. It can be best practice to operate in this sort of account separation, but customers want to have the flexibility to bring it all back together, to monitor and observe across these discrete accounts without any boundaries. The way we've solved for this in CloudWatch is with cross-account observability. You can now get a bird's eye view across multiple accounts. You can search, discover, and analyze your metrics, logs, and traces across your organization from a centralized single pane of glass. It's as if you were operating in a single account. It's easy to set up. You can use CloudWatch Console, AWS CLI and SDK, and AWS CloudFormation. So if we take an example, imagine you have an application deployed and running on multiple AWS accounts, and you have a centralized SRE or DevOps team that are responsible for this application. How could this help? So a key cornerstone of this is around logical groups of accounts. You take a selection of AWS accounts, which we call source accounts. So in our example, each one of these could be an AWS account that's running part of the application. It could also be separate business units within your wider organization. You then define monitoring accounts and you link these up. You can do this at an AWS organization level, so you can include all accounts within the org. A key benefit of doing this is that once you set it up, as you add or remove accounts, they're automatically propagated into the monitoring account. Or you can do it account by account. So you could select 1, 2, 10 accounts and group these together. And it's a logical group, so that gives you super flexibility to create these relationships based off your use case and your objectives. In one way, nothing really changes at the source account level. It still fulfills its function, it still gets its telemetry, you can still monitor in these accounts if you wish. But now you have the option to monitor from this central monitoring account. So when you log into the monitoring account, you get this single pane of glass view that I mentioned. You can see the metrics, the logs, and the traces from across all these associated accounts. So it gives you the flexibility to choose to operate and monitor at the cross-account level. So we're coming near the end. Before we close, I want to share some resources that may be of interest. First is the One Observability Workshop, a workshop where you can learn more about the AWS observability services, some of which I mentioned today. There's also the best practices. So this is a best practice guide on how you can start to use AWS observability for your specific use case. There's also a link here to Amazon CloudWatch. So thank you for taking the time to listen today. Hopefully I was able to share some insights, best practices, and tips that'll help you monitor and observe your applications running on AWS.